Welcome to the Sprint2 review for Team LA Hacks. Team LA Hacks is comprised of cadets Jenny Yan, Joe Suh, Jack Graham, Morgan Rabelais, Luke Williams, and Dan Park. Our Scrum Master is Colonel Chawar. Our goal for Sprint2, Team LA Hacks will continue to familiarize with all hardware systems and further implement the integration of each system with one another. More specifically, the Leap sensor will be mounted on the Oculus Rift and dynamically influence the scene in Unity. We will create a more complex Unity project and show the different methods that can be used on the Oculus. We will begin knowledge acquisition and create products, both demo and self-created, from Blender for 3D objects, and we will support the mechanical engineering goals, develop an understanding for the Myo band, and explore the possibilities of using the Google Glass. We allocated 116 hours of work time for this sprint and ended up doing 123.5 hours of work. One goal of the sprint was to use the Leap motion device as a controller for objects within Unity. This involved looking at Unity projects that had implemented this and making one of our own. Before this, we had always interacted with objects in Unity with the Leap sensor, but had never controlled an object directly with it. All we were able to do in Unity was grab or throw objects, not directly manipulate the motion of a player object, which is what we wanted to end up doing. We looked at some projects that others had made and could clearly see that it was possible to do this, and we used these examples to implement this into our own setup. Most of the examples we saw had very simple control schemes, such as this flying sim, and it was this kind of control scheme that we wanted our example to have. We had learned that very precise movement is difficult to work with using Leap, so we wanted to make simple movements the control scheme for our game. We took the rollerball demo that we had made in Unity during the last sprint and converted it so that it would take input from Leap motion to control the ball's movement instead of input from the keyboard. As you can see, we were successful in implementing this. The hand motions that we used were simple. Leaning the hand forward, put the ball to the north, backward put it to the south, and then panning your hand right would move the ball right, panning left would move the ball left. In the end, we were very successful in implementing this. Another goal of the sprint was to use the Myo band to control movements of a packbot. This involved learning how to use Myo on Windows, integrating it with ROS, and ultimately controlling the robot. Myo is designed to work with Windows, so we gained familiarization with the band by using it there first before attempting to port it to Linux for use with ROS. Here you can see that Joe is controlling a PowerPoint-like presentation using arm and finger movements read by the Myo. Motions like pinches, swipes, and arm twists can be read by the Myo. After long hours of debugging integration with Linux and ROS, we gained the ability to drive the packbot using Myo control. The commands are simple. Pivoting your arm turns the robot, an upward wrist makes it go backwards, a limp wrist makes it stop, and a clenched fist makes it go forward. The Myo band is slightly less versatile than the Leap motion since it can only be used with one arm, but is more consistent with reading fine movements. Both of these motion control devices have their pros and cons, but it is more likely that we'd be using the Leap motion in the future with our own project. The Myo band use was mostly for our mechanical engineering counterparts who wanted to control their packbot with it. The next task for the sprint was to learn to use Blender to create 3D objects that can be used with Unity. This involves setting up environments, completing tutorials, actually creating the objects, and putting them into Unity. We needed to learn how to use a program like Blender because there's no native method for creating complex objects within Unity, so another program became necessary if we wanted to be able to make our own objects and not have to rely on that which has already been made by others. As you can see here, the process of making a 3D object is not complicated, but it can take a lot of time and effort to produce anything complicated. Here, we start from nothing to make a fox figure. We start by making a 2D map of it and expand it into the third dimension when we are satisfied with the profile we have built. In this way, it is very similar to using a bandsaw to cut a piece of wood. The fox that Dan made here had many stages of development, even beyond the creation of the frame that it is designed on. After the frame was built, effects and textures were added to make it better. We explored making things from scratch using our own artistic abilities, and also made objects from tutorials to grasp how to use Blender best. Here you can see that Ginny has used a teddy bear tutorial and a mug tutorial to make more realistic objects. In fact, the intro that we had at the beginning of the video was also made using Blender. Our last main large task for the sprint was to integrate everything we had learned to use together. That includes Oculus, Leap, Unity, Blender, and external video. We wanted to be able to use live video with Unity, and we haven't learned how to do that yet, but we have learned that you can use pre-recorded video in Unity quite easily. Here you can see a video of our PackBot sitting on a cube within a Unity scene. Luke will now talk about the full integration that we were able to work with.
Hello, this is Cadet Luke Williams, and I'm going to be going over the integration of the Oculus Rift, the Leap Motion, and a Blender-created object within the Unity environment. Let's go over our hardware first. This is the Oculus Rift, and I'm going to be putting this over my face to look into our game engine. And with the positional tracker I have on top of the monitor, as I move my head left, the camera will move left in-game, and as I move my head right, the camera will follow. The Leap Motion is the black box that we've attached onto the Oculus, and that's going to track the position of my hand movements and display them into the game. And we can add some cool physics scripts on top of that to interact with objects within our engine. So this is the Leap Motion. I'm going to first open up my previously created environment to demonstrate some cool scripting effects that I want to work with just the Oculus and Unity. So when I press play here and put the Oculus on, one of the first new features that we're going to be able to see is the sphere that's floating around in front of the camera. I thought it'd be cool to try and integrate some mouse-related features into our future projects, and the Unity doesn't actually display the mouse onto the Oculus. So what I did to fix this problem, or work around it, was have the sphere follow around wherever the mouse actually would be. So now I can do cool effects like when I click on this box and make it fly into the air. And also, if I were to hover over the box and press the E key, I can bring it towards me and move it around with the mouse. If I wanted to make these objects disappear, like the sphere here, I can use some scripting and hit the F3 key to make it go away. And this mini-map over here, which displays my position on the map, I can make that go away if I hit F4. Of course, I can also make them reappear if I wanted to, with the same keys. Last but not least, we have this object over here, the Fox, which is Dan's Blender-created image that we've successfully imported into Unity. It doesn't have any high-quality textures or furs on it right now, but it's cool to us because we can now create whatever we want and import it into our engine. So we don't have to rely on what Unity has given to us or what other developers create. We can create what we want, and in the future we can add our own animations and textures to it. So this first part of the demonstration was really our first part in this project, working with interacting with objects and Unity. And after this, I'm going to show you a brand new environment that we created to work with the integration of the Leap Motion specifically with the Oculus Rift. Now I'm going to have a quick disclaimer to begin with. Our Oculus version that we're currently using, the development kit that we're working with, is running on a 0.8 beta. And it's not fully complete, there's some bugs with it, and it's not fully integrated with the Leap Motion itself. So here we can see on the Leap Motion's developer site, some of the poses are not currently tracked reliably in head-mounted display mode. So just pinch and rotate. So that's a crutch to us, but we're working with what we can, and we're going to improve as the environment improves along with us. So when I open and play my scene, we're going to be able to see that we can actually use my hands to interact with objects in the game. So when I lift my hand up, it displays a virtual image of the hand in the game, and I can use that to interact with other objects. And I've created these cubes in front of me to do just that. I can actually catch these cubes in front of me if I wanted to, and then push them out of the way. I've also created a pinching script that I've added onto these hands. So if I hold my hand up, look at a cube, and pinch, it brings the cube towards me, and I can let it go away and do that with other cubes as well, and fling them away. So it's really cool working with this. It's not perfect, of course. The tracking is not 100%, but it's cool to be able to actually interact with these objects in the game. Last but not least, we have this black box over here, which is what we're going to use to display video within our engine. So ideally, our end state might be to have a live video feed, but right now we're working with just regular video in our engine. Right now this is a regular box. If I pinch it, it'll I can actually carry it just like any other boxes. So let's start by putting our video feed somewhere higher than it was, and then I'm going to hit the F2 key to turn it into a kinematic mode. That means I can't actually interact with it at all right now. It's stationary. Now if I hit F3 key, it just activates a script that makes it orient to where it's facing me, or where it was originally facing. Now I'm going to pull up, using another scripting feature that I implemented, some of these spheres in front of me that act as like a virtual remote. So I'm going to first hit this right sphere, which acts as the play button. As we can see, the video has started playing, but it's a little small, so I'm actually going to use the left sphere over here to increase the size of the video. Of course, the opposite reaction, if it gets too big, would be to hit the lower sphere and decrease the size. These other spheres change the cube in various ways as well. So if I wanted to turn it left or right, I can hit these middle spheres. And the spheres right here will turn it up and down. Of course, I can return it to its original position if I might mess up, for example, or turn it in some way I don't want to by hitting the F3 key. Now let's see if our pause buttons work as I wanted them to. And so if I hit the red button, the video will stop. And if I hit the other red button now, the video will play again. So the color switch as I pause and play the video. So now we can see this really acts as a virtual remote. I can touch these buttons and play and pause the video as I want to. Of course, if I wanted to resize this video and move it around entirely, I could do that by shrinking it, turning off kinematic mode, and then I could really move it wherever I wanted to.
In addition to the tasks we needed to complete in order to achieve our main objectives, we completed a number of tasks that were geared towards the administrative end of completing the sprint, like sprint planning, improving the product backlog, making the video, creating a new Unity environment, attending a luncheon with the Honorable Heidi Shue to show off our stuff, and a trip to the Museum of Science in Boston to see a presentation by Pixar about 3D modeling. Jenny made a trip to Boston earlier in the sprint, knowing that she was going to be building 3D objects and that the knowledge she gained at the presentation could be valuable. While there, she learned more about a few subjects on 3D objects, such as extrusion of objects, rendering objects, and lighting them to make them look more 3D in animation. The final thing worth mentioning that we did during the sprint is complete the block diagram for our project. This picture outlines the link between all the hardware and software that we will be using, from the Oculus and Leaf into the PC, using the software that we will use to create the environment and run our scene, and then going back out to the Oculus for the Wear to see. For our next sprint, we want to learn new scripting skills, add animations to scenes, continue developing with the mechanical engineering team as required, and get live video feed into Unity. Thank you for watching.